Okay, so we are now looking at ET39, 18th of June 2011, and we're doing question 7. So, a three-phase delta star connected transformer steps down voltage from 33,000 volts to 11,000 volts. The output terminals, when fully loaded, a current of 15 amps flows across the transformer's primary windings. Assuming no losses, calculate the full primary line current. So, first, we want to draw the picture, otherwise we'll make mistakes. So it is a delta star. So delta star. And it's a 33,000 to 11,000. The terminals, and we've got 15 amps. Now, we want the full load primary line current. So we've got 15 amps there, sorry. Let's read properly. 15 amp flows in the primary windings. Therefore, we want how much is the line current. So, when the current comes here, it splits and goes both ways. So what we do is we divide it by the square root of 3 going in the way in reverse. 15 amps going back, we multiply by the square root of 3. So we have 15 times square root of 3, and we end up with 25.98 amps. And that'll be in all three, 25.98 amps, 25.98 amps. Now, we want this full load secondary line current. So to do this one, we need to calculate our ratio here, which means first we need to get our voltage between here and here. So for that one, it's dividing by square root of 3. So 11,000 divided by square root of 3, because we reduced the voltage. And so that gives us 6350.85 volts. And we know that this side here was 33,000 volts. So we go 33,000 divided by answer gives us a 5.196 to 1 ratio. So at this stage, we don't actually need to turn it into whole terms or anything. We just need the comparison. But we now have a ratio. And now I realize I'm doing this when I didn't need to. What I should be doing is I had 11,000 got there. I should just use my power formula. It'll be simpler. So power equals root 3 times V line times I line. So or VA, I should say, equals root 3 times V line times I line. Being a transformer, and we're not doing a resistive load. And so we can actually work out for this side. So VA equals root 3 times 33,000 times by 25.98 equals, so root 3 times 33,000 times by 25.98, and we get 1484956. 444, rounding up, and that is our VA rating. 1484956. Now we can reverse our formula to calculate I line. So our original formula VA equals root 3 times I line times V line. We divide both sides. by what we're trying to get rid of on the one side. So in this case, we're trying to calculate I line. So we divide by root 3 times V line, and then we do that on this side, root 3 times V line. The root 3's cancel, the V lines cancel, so we end up with I line equals VA over root 3 times V line, which is our 11,000. So with our previous value still loaded in the calculator, we can put that in because we've got the VA, and then divide by bracket square root of 3 times 11,000. And we get equals 77.94 amps. So that's the full load secondary current. Now we move on to the next part. Total kVA rating. They must have wanted me to do it the first way I was trying to do the calculation. So the total kVA rating, we've already written down. That's that value there. And then they want two methods used to cool transformers. Air cooled and oil cooled would be the ones I would probably pick, or forced air cooled. Take your pick. Let's see what they had for the answer sheet. That's right up there. Easy to find it. I hid it inside the thing. So, do they agree with me? Primary line current 25.98. They had 25.98. Secondary one 77.94, 77.94. Match again. KVA rating. I forgot to design 1,000. So it's 1485, 1485 once we round up. That matches again. Air cooled, oil cooled, pumped or natural, forced or natural are our answers, potential answers for B.